Picture this. You leap into a tunnel that plunges straight through the Earth. Where would you emerge? Many might imagine you'd magically pop out the other side. If Earth were a hollow apple, perhaps, but our planet is far more intricate. Think of it as a colossal onion with layers upon layers of rock and metal. Let's peel back these layers and embark on this exhilarating hypothetical journey. Let's embark on an incredible journey, starting with the Earth's crust, the very ground beneath our feet. This outermost layer is where all life thrives, from the towering mountains to the mysterious ocean depths. It's the bedrock of our continents and ocean basins. Surprisingly, the crust is as thin as an apple's skin compared to the whole fruit. Despite its thinness, it's incredibly diverse, made up of various rocks and minerals. Beneath the crust lies the mantle, a colossal layer stretching down about 1,800 miles. This thick layer of hot, dense rock is always on the move, driving the dance of tectonic plates. Picture the consistency of very thick caramel. The mantle's slow, creeping flow is what triggers earthquakes and volcanic eruptions. It's hot enough to melt rock, but immense pressure keeps it mostly solid. The mantle's heat also fuels geothermal energy, a powerful resource. Venturing deeper, we reach the Earth's outer core, a churning sea of liquid iron and nickel. This layer is vital for generating the Earth's magnetic field, our shield against harmful solar radiation. Temperatures here soar to nearly 10,000 degrees Fahrenheit. The intense heat and swirling liquid metal create electric currents. That's hotter than the surface of the sun. These electric currents generate the magnetic field that stretches far into space. Finally, at the Earth's core, we find the inner core. This solid sphere of iron and nickel is under immense pressure. It's a solid ball of iron and nickel, even hotter than the outer core. The inner core's heat is a remnant from the planet's fiery birth and radioactive decay. So about that tunnel straight through. It's a mind-blowing concept, but with today's technology, it's a journey we're not yet equipped to undertake. The extreme conditions make it a challenge beyond our current reach. Imagine you've cracked the code to withstand the Earth's extreme heat and pressure. Picture yourself in a high-tech suit designed to brave the fiery core and the crushing weight of the planet's layers. Now, what if you dared to jump into this colossal tunnel? As you take the leap into this abyss, your thrilling journey begins. At first, you'd plummet, accelerating rapidly as gravity takes hold. The force would pull you down faster and faster, like a skydiver in free fall. As you dive deeper, your speed would become astonishing, racing towards the Earth's center at breakneck velocity. But then, something fascinating happens. The mass above you starts to tug you back up. The gravitational forces from the layers above begin to counteract your fall. This means you decelerate as you near the core. The closer you get, the more these forces balance out, slowing your descent. But you wouldn't stop there. You'd shoot past the Earth's core, propelled by your momentum, only to slow down again as you approach the surface on the other side. Welcome to Section 4, the physics of a planetary plunge. Imagine embarking on an extraordinary journey straight through the Earth from one side to the other. This mind-bending thought experiment reveals some of the most captivating principles of physics. Picture a pendulum swinging back and forth. Now, imagine yourself falling through a tunnel that pierces the center of the Earth. You'd experience a similar oscillating motion, just like that pendulum. As you plunge through the Earth, you'd oscillate back and forth, your speed gradually decreasing with each pass. This happens due to the conservation of energy and the inevitable loss of kinetic energy to friction and air resistance. Eventually, you'd come to a halt at the Earth's core, feeling gravity's pull from all directions. Here, you'd reach a state of equilibrium where gravitational forces from all sides perfectly balance each other out. But wait, there's more. We must consider the Coriolis effect. This phenomenon, caused by the Earth's rotation, influences the path of any object moving within the planet. Because our planet spins, your path wouldn't be a simple straight line. Instead, it would curve, adding a fascinating twist to your journey. You drift slightly sideways as you fall, thanks to the Coriolis effect. This sideways drift would make your path through the Earth an intriguingly complex one, full of unexpected twists and turns. Section 5. Destination, the Antipodes, almost there. Now let's talk about where you'd actually end up. It wouldn't be the exact opposite side of the Earth. Remember that sideways drift we mentioned? That's the Coriolis effect in action. It means you'd likely end up near your antipode, but not exactly on it. Imagine starting your fall in Argentina. You wouldn't end up in China, but maybe somewhere in the Indian Ocean. It all depends on where you started your incredible journey. Our Earth is a mesmerizing and intricate marvel. This imaginative journey, though purely science fiction, highlights the astounding forces at play beneath our feet. From the blistering heat of the core to the delicate pull of gravity, Earth is an endless source of awe and discovery.